Hello friends, this video on Redox reaction part 10 is brought to you by examfear.com. No more fear from exam. So here the question is pretty simple. The stock form is given. You write inside the formula. Mercury chloride, this HgCl2, right, is 2. Nickel sulfate, NiSO4. Tin oxide, SnO2. Thallium sulfate, Tl is thallium sulfate. Iron sulfate, iron with 3, that is Fe2SO4 3. Chromium oxide, Cr2O3. Why? See, because this is oxidation number of plus 3, right? So plus 3 into 2 is 6, and this is minus 2 into 3 is 6. Overall it is 0. Similarly, if you see here, this mercury has plus 2, chlorine has minus 1, overall 0. Nickel sulfate, if you see, SO4, this is plus 2. And SO4 generally total you get is minus 2, right? Total whole thing SO4. So you get 0. Similarly, SnO2 also, if you see, this is minus 2 into 2, minus 4, and this is plus 4, plus 4. This is also, if you see, this whole thing is minus 2, this is plus 1, so plus 1 into 2 plus minus 2 is equal to 0. That's how you write the formula. We have to give a list of substance where the carbon exists, the oxidation state of minus 4 to 4, and for nitrogen from minus 3 to 5. So this is something you will learn on experience. The more you solve questions, the more comfortable you will become with more and more compounds, and you can solve this question. So let's start this question. Carbon has minus 4 in CH4. I know this because hydrogen is plus 1. So let's talk about minus 3. So if you make it C2H6, carbon will be minus 3. Correct? Because hydrogen will be again what? 12. Minus 6 into 2 is 12. Sorry, minus 6 plus 6 into 6 into plus 1 plus 6, and this will become minus 3. Plus 6 by 2, right? So minus 3 is also that. To talk about minus 2, what I can do is I can take this, instead of hydrogen I will make it chlorine. So this becomes CH3Cl, so this will become plus 3 and minus 1, right? This is plus 1 and this is minus 1, right? So this is 3 into 1 plus 3, and this becomes minus 1, right? The whole thing is 2, so this has to be minus 2. This is minus 2. Similarly, if you want to make it minus 1, you can take a triple bond like this. CH, triple bond, CH. It will have minus 1. If you want 0, you can make it 2 hydrogen and 2 chlorine, right? So both of them will cancel, right? Carbon will be 0. If you want to make it 1, what you can do is you can make something like this. CCl, triple bond CCl. So this will become plus 1. Just similar to this, instead of hydrogen I have chlorine, so it is plus 1. I want to make it plus 2, so I can make it 3 chlorine 1 hydrogen, right? 3 chlorine 1 hydrogen. If you want to make it plus 3, in that case I can make something like this. CCl3, and here we have CCl3, right? This is minus 1, this is minus 1, so minus 6, so minus 3, minus 6 total, right? Minus 6 divided by 2 is, minus, this becomes, if you see, if you make it x and x, you will get 2x minus 6 is equal to 0, you get x is equal to 3. Similarly, for plus 4, what you can do is pretty simple actually. You make it CCl4, you get plus 4. This is how you get, just by playing with hydrogen and chlorine, you can get all the oxidation state of carbon from minus 4 to plus 4. Similarly, let's do for nitrogen. Nitrogen you want minus 3, just NH3, if you see, it will have minus 3 because there is plus 1. Pretty simple, minus 3. Similarly, for minus 2, what you can do is you can write N2H4, correct? So minus 1, what you can write is, you can write N2H2. Because if you see this guy is +1, all +1 here, right? So this will give you -2 and this will give you -1. For 0 you can write nitrogen in the free state, correct? For +1 what we can do is we can write N2O, because this is -2, this becomes +1, right? For +2 what we can do is we can write NO instead of N2O. This is -2, this becomes +2, right? For +3 what we can write, we can play with this oxygen only, N2O3. This is -2, this will give you +3. For +4 also we can play with oxygen, right? This is -2, this becomes +1. So thus I have various oxidation number. See, for a positive oxidation number I am playing with oxygen, for negative I am playing with hydrogen. Here also for positive I was playing with chlorine, and for negative I was playing with hydrogen. So mix of these two help me to get the values. Let's take some more example. The question says, while sulfur dioxide and hydrogen peroxide can act as oxidizing as well as reducing agent, but ozone and nitric acids can only act as oxygen. So it's all about the oxidation number. Let's try to find the oxidation number of SO2. So in this case, I have the formula free image of human face. It's not free, it's not iron. O we can use -2, let this be x, this becomes x minus 2 into 2 is equal to 0. So x is equal to 4. This is the oxidation state of 4, right? And I know the range of sulfur is what? +6 to -2. So thus if you see, it has scope of oxidation also, reduction also. So if you see, this guy can act as oxidizing agent as well as reducing agent. We talk about H2O2. So here we know that we have O and we have a special rule. So oxygen here will have oxidation of -1, and the range of oxidation state for oxygen is 0 to -2. So this guy can become 0, this guy can become -2, so that we can increase the oxidation number, it can decrease the oxidation number also, right? So it can act both as oxidizing as oxidizing. Let's talk about ozone. So ozone is O3, that is 0, it's free state, and range of oxygen is what? 0 to -2. So there is no scope for oxygen to increase it, right? It can't go to 1, right? The only thing it can do is it can reduce the oxidation, that is, it can act as oxidizing agents, right? They can act as oxidizing agent only, because they'll get themselves reduced. Similarly for nitric acid, H and O3, let's find it with the formula. O is -2, H is +1, let this be x. You get 1 plus x minus 3 into 2, 6 is equal to 0. You get x is equal to +5. And for nitrogen, the range is +5 to -3. So you can always get reduced because it is already +5, right? You can lower the value, it can't increase the value, that is not possible. So it is only oxidizing agent. This is oxidizing agent. The question says that AgF2 is very unstable. However, if formed, the compound acts as a very strong oxidizing agent. Why? So let's find the oxidation state of elements in AgF2. Free image of human face, right? So this is not applicable, this is not applicable, there is no oxygen, no hydrogen, fluorine is there. -1, this becomes +2. So if you see, +2 oxidation state of Ag is very unstable, and +1 oxidation number of Ag is very stable. That's why +2 oxidation state always want to become +1, right? So Ag +2 always want to become Ag +1. Because this is stable, this is unstable, right? So this guy Ag +2 is reducing to Ag +1, so it is a good oxidizing agent. So because it itself get reduced to Ag +1, so it acts as a very strong oxidizing agent. The question says, whenever reaction between oxidizing agent and reducing agent is carried out, the compound of lower oxidation state is formed, the reducing agent is accessed, and the compound of higher oxidation state is formed, the oxidizing agent is accessed. Justify this. if we have oxidizing agent plus reducing agent, right, it says that if my reducing agent is more, compound of higher oxidation number is formed. Let's take some examples for this. Let's take carbon and oxygen, right? So if I have carbon and oxygen, so in this case I know my oxygen is oxidant and this is reductant, this is oxygen, right? So with this, if you put excess of oxygen, what you get? CO2. And if you put carbon excess plus oxygen, what you get? CO, right? Limited oxygen if you supply, you get carbon monoxide. So let's see the oxidation number of carbon in this. This is -2, this becomes +4. This is -2, this becomes +2. So you see here, with more oxidant, you get higher oxidation number, right? So a compound of higher oxidation state is formed if the oxidizing agent is excess. So if you see in this case, carbon is getting oxidized, oxygen is getting reduced. So oxygen is the oxidizing agent and carbon is a reducing agent, right? So carbon is a reducing agent and oxygen is the oxidizing agent. If you pour more oxygen, you get higher oxidation state. If you put more carbon, which is my reducing agent, I get lesser oxidation state. We can take more examples. We can take example of potassium and oxygen. Same thing. If you put oxygen as excess, right, you get K2O2, and if you put potassium as excess, you get K2O. In this case, this is -2, this becomes +1. It's -2. This becomes +2. Is it +2? No, +1. And this is +2 only. And this becomes +1. So if you see here also, right? If you see here also, you put more oxidizing agent, you get higher oxidation number. You get lower oxidation number. Correct. Similarly, you can take the example of P4 and F2. Right? If F2 is excess, you get PF5. If P4 is excess, you get PF3. So here if you see, this is -1, this is -1. So here this becomes +5, here becomes +3. So if you see again here also, excess oxidizing agent will give you higher oxidation number. Okay. So with these three examples, we can tell that you have excess oxidizing agent, you get higher oxidation numbers. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.